This video is a walkthrough setting up Amazon AWS and a free cloud-hosted database. To complete all the steps in this video, you're going to need a cell phone and a credit card, which will not be charged in any way, only verified by Amazon. So let's get started. AWS stands for Amazon Web Services, and that means everything from web hosting to application hosting to database hosting and more. The first step is sign up. Navigate to aws.amazon.com, click on Create a New Account. Select a username. We will use Test Account for this demonstration. Select the New User option and click on Sign In. Fill in the blanks, store your new password in whatever password management system you have, and click Create Account. Select Personal Account here to keep things simple, and fill in the rest of the form. Prove you are a human or other sentient creature by typing out the security check. And if you agree with the AWS customer agreement, click your agreement and then click Create Account and Continue. The next step is to provide a method of payment in the event that you use chargeable services. Now, we use many free AWS hosted databases for demonstration and testing here at Informodal, and we never pay more than a few pennies per month. And we'll be talking about how to keep services free or nearly free in this video series. So, provide a credit card as a placeholder, and if the name and address associated with that card are not the same as the last form you filled out, go ahead and click the Use a New Address radio choice and fill out the rest of the form. When you're done with that, click Continue. And Amazon is going to verify who you are by calling you. When you answer the call, say hi as the system is triggered by sound. Using your phone's dial pad, key in the PIN that appears in the web browser. And that's that. Click Continue to select Support Plan. Select Basic, which means free or nearly free. And let's sign in with the ID we just created. At this point, we'll be at a high-level console with lots and lots of stuff in it. Don't be intimidated. Amazon has actually gone to great lengths to make this all pretty accessible. And in the next video in this series, we'll set up an actual database server in just a few short minutes. So we're signed up with a new account, and in this video we're going to set up an actual database server and database in very short order, and in the video that follows we'll actually connect to that database and exchange data. So, what kind of database? RDS stands for Relational Database Service. It's the same relational technology we already know, even the same vendor offering in many cases. So we'll be offered SQL Server, MySQL, Oracle. It's really the quickest, easiest, and least expensive path from where we are today to where we're headed. The cloud. The other major database headings, DynamoDB, Elasticache, Redshift, DMS, these are all advanced AWS offerings that are just past our scope here. So click on Get Started to launch the process of building out a server. For this demo, let's select SQL Server, Express, or the free edition, and click the appropriate Select button. Select License Included. Make sure you've selected the latest engine version. That's the actual vendor software version. In this case, for example, Microsoft SQL Server 2014. The instance class is the hardware level we'll be leasing. Select the first choice, which is the smallest one, to keep this all in the free tier. Storage type is going to be great at general purpose, and since it's free and SSD tech is crazy fast, there's no point downgrading to less or upgrading to more. Allocate what space makes sense. Remember that this number should include your content plus enough to back it up, so figure on at least 2x for your data to allow for backups. Amazon currently recommends 100 gigabytes to prevent latency, etc., but for simple databases, not supporting hundreds of web users, really any reasonable size should be fine. In this case, 20 gigabytes is fine, as we're allowed 10 in terms of database size for SQL Server Express Edition, and a backup adds up to about 20. Every database needs a name. Enter it in the DB instance identifier field. Now, this is a bit different from the local database on your network, where naming consists of server / SQL instance, for example. In this context, the database name is the instance of the SQL Server. Every database also has an SA or a master account. Enter one here and create passwords and store those, and click Next Step. Okay, so on this screen we define security and access. The way AWS works is by assigning you a VPC, or Virtual Private Cloud. It's essentially a block of virtual IPs in an addressing scheme called CIDR, which we'll talk about in another video. As you can see, a default VPC has been created for our account. Any services we build in the Amazon cloud will live in our VPC. In that block, you define your instances. Subnets are how you separate and address virtual networks so you can control traffic between them. Publicly accessible means that data can be routed from your subnets to the outside internet and back. It doesn't define how or what security is defined around that. Because we'll be accessing our data from outside AWS, we'll set that to yes. Availability zones are how AWS provides redundancy. Each zone represents a separate physical Amazon server farm, and if one fails, then services fail over to the others. For now, leave defaults for all settings, but make sure that Create New Security Group is selected. This is going to create a set of rules by which the new database instance will be protected from all outside traffic except our own. Ignore the Windows authentication portion for now. That's a pay service, and we will address it in a separate video. Database port is industry standard 1433. DB parameter group and option group are used by Amazon to manage product offerings and subscriptions. Leave those at default for now. Backup and minor version upgrades are best left on automatic. The best use of a hosted automated database offering is that it's hands-off and it's maintenance-free. But if you prefer to, you can select time spans for backup, and you can also do the same for minor version upgrades, or you can freeze current server version for manual updating. Okay, we're pretty much done with setup. Click on Launch DB Instance. This will take a few to several minutes, at which point we'll return in the next video to connect to our new database and exchange data. Our new database is doing a first backup, basically an empty backup. Now that our database is available and Amazon has completed the automated setup, provisioned virtual spaces and hardware, and set up maintenance schedules and done much of the work normally required of an IT staff, we can access it. We can monitor our instances' performance anytime here. In addition, this is where we can see how our endpoint is defined, our point of access for this instance. Highlight this line and copy it. We're going to use this to connect to our server. Let's open SQL Server Management Studio. This is the easiest way for me to connect, but if you're an Excel user, don't worry. The next video will show you how to get to your AWS database from Excel as well. The server name is comprised of a regular IP address and port number, but there's a prefix to all that. The first two portions of the address are the AWS specific CIDR enabled addressing we talked about in an earlier video. You don't have to worry about it, you just should be aware of what comprises it. Make sure you do not include the colon between the IP address and the port number. Use a comma or take the port number out altogether, as 1433 is the default anyway. Populate the login with the master or SA account we created when we set up our database in the last video, and enter the password as well. And bam! We are hosting a cloud database. So if you're having trouble connecting to the database, let's take a look at some settings that are commonly found to be in error. This is probably the most, what we're going to cover is probably the most common reasons for failure. VPC is Virtual Private Cloud. So it's basically a way of supernetting. It's basically a way of taking Amazon and making Amazon an internet within the internet. So Amazon has regular internet gateway addresses, but on their side of things, on the inside of the Amazon circle, are supernets. There's a logical addressing system that allows basically and virtually infinite addressing schemes to be shared amongst as many clients as they want.
So you can have a virtual network that's got 65,000 available nodes on it, no big deal. In fact, you can have several of them. By default, the VPC that's created when you sign up has certain default features. It's got 3 subnets. It's got a few ACLs defined out of the box, so to speak, and some security. What we do during the process is we say we're going to enhance and enable security by specifying that the only traffic allowed is between the database server and my PC. We saw that when we did the security groups. This is the default that gets built sort of anytime you build a VPC, and that happens automatically when you sign up. But this is the one that we asked it, based on the wizard interface, to create for us. And you'll see that the inbound rules reflect a source of me. So if the data is not coming from me, and it is not port 1433, it's simply not getting to the server. It's just not getting it. So these are the kinds of things to look for. Make sure that the outbound rules, unless you have some reason to tie them down, are just loosely specified for all. Destination of 0 implies any address, masked this way. Inbound rules, this has to be your address if we're going to keep this tied down. If you don't know what that is, it's simple enough to open a Google tab and simply ask, what's my IP? It'll come up right away. As you can see, 70.127.211.15 is the address here. So with respect to what else to look for, make sure the network ACLs are in place. Make sure that we've got inbound rules and outbound rules that look just like this. Make sure that those rules are associated with each of the subnets that are in turn associated with the VPC. Once that's in place, there's very little reason for this not to work correctly. One of the little sort of gotchas that I discovered along the way very early on was if you go to manage your RDS database and you open up an instance and you look at this endpoint, you'll find that, let me blow this up, you'll find that this endpoint syntax is in standard IP sort of syntax where you've got some internal addresses and then a truly internet-worthy address, rds.amazonaws.com, and then the colon that represents what port you want to communicate with. I copied this and put it into my connection string for SQL Server Management Studio, and it failed because SQL Server Management Studio prefers to see a comma, at which point everything worked.